Greetings class, we're going to go over 1.2 visualization of data. We're going to cover quite a few different topics. I might skip over some of the examples, but I'll do my best to go over as many as possible. So first example, analyzing a list of data. Let's find the maximum, minimum, mean, and the median. Maximum is obviously the biggest number. Minimum is the smallest number in value. The mean is the average, and the median is the middle number. So obviously the maximum is 5. I want to do something really quick. We're going to rearrange this data, okay, from -4, 2, 3, and 5. And so this is the minimum, so obviously we know what that is now, and the maximum, okay, and we're going from smallest to greatest, left to right. And so that allows us to find the minimum, which is -4. The mean is the average, so you're going to add all of the values up, okay, add them all up, and divide by how many numbers there are. There's 1, 2, 3, 4, and that's where this come in. N is equal to 4. And so when you add them all up, 5 plus -4 is 1, plus 3 is 4, plus 2 is 6. And so really it's actually 6 over 4, but that reduces to 3 over 2, which is 1.5. So that is our mean. Okay, and the last thing is our median. Median is our middle number. In order to find the median, again, we're going to arrange the numbers from least to greatest. And then we take the middle two numbers. Okay, so the middle two numbers are 2 and 3. See them here, 2 and 3. You add them up and divide by 2. So our median is 2.5. Okay, so we're going to find the domain and range of a relation. All right, so this table shows the time in hours it takes to drive various distances in miles. Let's express the data as a relationship S. So this is really a set, okay? This is what we're looking for, a set. And we're going to express it in data points, okay? So let's take the solution here. Notice we're expressing it as a set S. And this is how you express it with these brackets here, okay? Brackets, and then this is our first point right here, 60 miles in 1 hour. So our second point, 120 miles in 2 hours. Our third point, 150 miles in 2.5 hours. Let's find the domain and range of S. So again, we're going to express data points. Domain are all values of X, okay? And your range are all values of Y. All right, so for this problem, the domain, notice we're calling this the domain and this is the range, okay? And so they're just listing domain, D, parentheses, these parentheses are a big deal, and listing all of the values of our domain. And again, for range, notice they're just listing range. So if I ask you a problem, this is the appropriate way to express it. And they're just listing, notice 1, 2, and 2.5. All right, so again, I'm going to, this is set S, and we're going to quickly go through this. So again, you can see data point here, 0 and -3, 1 and 2, and -2 and 2. So the domain and range of the relationship, right? Notice they're listing all of the values of X here, okay? All the values of X, so 0, 1, and -2, and they're listing them in order, right? From least to greatest. And now the ranges, notice there's only 2 values, but there's 3 points. Why? Well, because if you look here, you have -3, and then you have 2 twice, okay? You have 2 twice. So we found the domain and range of the relationship. So again, you need to list it as domain equals brackets and list your values. Okay, so notice if there is a value that's repeated, you only have to list it once. Second thing, we're going to determine the maximum and minimum values of the x and then the y value. So for B, of all of the x values, the minimum is -2 and the maximum is 1. And again, you can see this in your domain is equal to -2, 0, and 1, right? And then again for the range, right, is -3 and 2. And well, that's your minimum, right? Your minimum and your maximum. So again, really you use the previous answer A to answer this question. And it's typically how these problems go. So again, so part C and D, we're going to plot these points and then we're going to label them. Okay, and here they are plotted. If you do not know how to plot points on a graph, I unfortunately do not have the time to take here to show you how to do that. But I can, if you email me, I can send you some videos to watch on how to graph points. So for example, 4, all right, these are each points right here. Okay, so really we have x and y. Typically time is your x values. You have 1970, 1980, 1990, and 2000. Right, and so notice that I'm just going to put millions here, and we're going to do 4, 18, 55, and 69. Now these are TV subscribers, okay? I'm curious to see how many TV subscribers we have in 2018, right? That's almost 20 years later. So it'd be interesting because we've diversified the way we've watched TV. So in 2000, really you just had cable. YouTube hadn't even happened yet. YouTube came out 5 years later in 2005. So here are our graphs. So these are data points, right? We have 1970 and 4, 1980 and 18, 1990 and 55, 2000 and 69. So this is a table, and these are points, all using this data that's provided. So next point, we're going to graph it. So again, 1970 is this one, right? 1970. This is 1980, 1990, and 2000. And so they connected the dots here, and again, subscribers in millions. This is a scatter plot and a line graph. They're connected. Notice they're connected and the line graph, and they're not connected as a scatter plot. All right, let's find the distance. So the distance formula, does it give it to us? Okay, it doesn't give it to us. So here's the problem, but the distance formula is equal to the square root of y2 minus y1 squared plus x2 minus x1 squared. And so because we're adding, I don't really think the order is a big deal. So in this case, this is, notice x. And so now they're doing it x1 minus x2. It's fine as long as this is y1. And that's the case. So notice 3 is y1 and this is y2. So this is x1, y1, x2, y2. So let me just rewrite it the way they're doing it here. So this is just x1 minus x2 plus y1 minus y2. Doesn't really matter in this case the order because we're subtracting and we're adding each term and squaring. We're just subtracting on the inside. Okay. And so notice these points are plugged in. Where did we get this 5? Well, here, x1. Where do we get the 7? Well, here, x2. And where do we get the 3 minus a minus 2? Well, this is 3 minus a minus 2. Notice that there's a minus here and a minus here. Really got to keep your bookkeeping straight. So this is 144 plus 25, which is equal to the square root of 169, and your final answer is 13. So key thing here is the distance formula. One of your questions in your classwork is, what is the distance formula? And give one example. Well, here's an example for you. This is finding the distance between two moving cars. I'm going to skip this for the sake of time. You can read through this again, just plotting some points and find the distance between them. Okay, this is using the distance formula. And here it is. So key thing is, were you able to find the points, right? And then plugging it in. So again, x1, y1, x2, oops, y2, x2, y2. So again, x1, x2, this is y1, and this is y2. All right, and so approximate distance is 91.1. I skipped through the preliminaries just to get to the, again, the distance formula. All right, so let's find the midpoint segment. The midpoint, it's actually two different points. So this is x is equal to x1 plus x2 over 2. And y is equal to y1 plus y2 over 2. So you're just finding, let's consider the average. Oops. The average. You're finding the average between 2 points. So let's plug those values in. So again, here's a formula. And so notice 5, x1 and x2. We add them up. 5 plus 3 is 8 divided by 2, which is 4. And y1 and y2. -9 plus -1 is actually -10. Divided by 2 is -5. Don't forget your negatives in here. Okay, so finding the midpoint is pretty simple. Okay. Again, this is another midpoint formula application. I'm going to kind of skip through here. So 1960 was 179 million. So 1960, there's 179 million. In 1980, there's 228 million. Okay, use this formula to find the midpoint formula and estimate the population of 1970 and see how close it is to the value of 203 million. Okay, so we're going to, again, add these up, right? We added the years up. 1960 plus 1980 divided by 2 gives us 1970. And 179 plus 228, right? 179 plus 228. And then divide by 2 gives us 203 million. Okay, so the midpoint formula estimates a population very close to the actual population. All right, so computing with the calculator, let's find the radius and the center of each circle. So these are formulas for a circle. Really, x minus h squared plus y minus k squared is equal to r. Okay, this is the formula for a circle. All right, so if there's no, notice here, there's no minus h or minus k, and so the center is probably right at 0. Okay, and notice the radius in this case is 100, oh, sorry, squared here. And notice this r squared here. So you can kind of guess the center is actually HK and the radius is R. So let's take a look at A. I don't know how much they give us. And In this case, it's 0, 0, right? Because h, there's nothing here. There's no x minus anything. So it's just 0. And so if r squared is equal to 100, well, you take the square root of both sides, right? So if r squared is equal to 100, square root, and that gives us r equals 10, which is how they got their answer here. All right, so the center is 0, 0, and the radius is 10. Now let's take a look at B really quick before they give us our answers. So again, here's your formula, right? So in this case, this is x minus a minus 1, right? And this gives us x plus 1, all right? Which is what they have here. So our h is actually minus 1 for B. And here, it's actually y minus a minus 2, which gives us y plus 2, which is what we have here. And so in this case, our k is negative 2, and r squared is equal to 6, so r is equal to root 6. Okay, so notice here hk is minus 1 and minus 2. Why? Because of what I explained to you over here. And r is root 6. And this is the center and the radius. So now we have points, right? And we're going to go backwards. So the first way we had an equation, and we were trying to find the center and the radius. And so now we have a center and a point on the circle. So let's graph the circle. Okay, again, we're finding the radius. Notice we're using the formula, we're using the distance formula, right? And so our radius is 5. And so now with this center point, you just plug all the values in. So x minus 2, and then and then y minus and minus 3, which becomes y plus 3, is equal to 5 squared. And here is our equation. So I'm going to expect you to be able to do this as well in homework. Okay, and here's the graph. You can use Desmos. Desmos. It's a pretty good graphing system. And you just type in Desmos graphing on Google. I will probably post a video on how to do this at some point. All right, so equation of the circle, here's another one. I'm going to skip through this. And viewing settings on your calculator. So again, I'm going to skip through this as well. And this is the end of the video, because you have to be able to just plot the points and use it on the graphing calculator. So I think I'll post a video at some point using how to use Desmos and how to do these things.